Hi dear students, Santosh here, and today I am going to deliver the lecture on building construction and design, lecture number 1 on introduction to building. This is new subject and very important as far as civil engineering point of concern as well as for competitive type of examinations. So if you have not subscribed my channel, then I am requesting you to subscribe my channel and let us start the lecture first. Okay. First of all, what is building? Building is defined as any structure for whatsoever purpose and of whatsoever material constructed at every part thereof, whether used as a human habitation or not, and includes foundation, plinth, walls, floors, chimneys, plumbing and building services, fixed platforms, veranda, balcony, cornice means projections, and signs and outdoor display structures. Broadly speaking, building consisting of three parts. First is the foundation, second is the plinth, and third is the superstructure. थोडक्यात बिल्डिंग ही 3 भागांची बनलेली आहे. पाया म्हणजे फाउंडेशन, प्लिंथला प्लिंथच म्हणतो आपण, अँड थर्ड इज द सुपरस्ट्रक्चर म्हणजे स्ट्रक्चर अबोव द प्लिंथ इज कॉल्ड ॲज अ सुपरस्ट्रक्चर. देन व्हॉट इज फाउंडेशन? इट इज द लोएस्ट आर्टिफिशियली प्रिपेअर्ड पार्ट बिलो द surface of the surrounding ground which is in direct contact with the substrata or a subsoil and transmit all the loads to the subsoil. म्हणजेच फाउंडेशन हे असा पार्ट आहे की जे सुपरस्ट्रक्चर आणि प्लिंथचा लोड घेतं आणि त्याच्यामधून तो लोड सबसॉइलला ट्रान्सफर करतं. देन प्लिंथ, इट इज द मिडल पार्ट ऑफ द स्ट्रक्चर अबोव द सरफेस ऑफ सराउंडिंग ग्राउंड अप टू द सरफेस ऑफ द फ्लोअर और फ्लोअर लेवल इमिजिएटली अबोव द ग्राउंड. प्लिंथ ही साधारणतः 60 ते 70 सेंटीमीटर ग्राउंडच्या वर ठेवली जाते, कधी कधी जास्त पण ठेवली जाते. जेवढी जास्त प्लिंथ तेवढे बिल्डिंग ॲट्रॅक्टिव्ह असते आणि परत सराउंडिंगपासून ती सेफ पण दिसते आणि ॲस्थेटिकली अपिअरन्स चांगला दिसतो. व्हॉट इज प्लिंथ? इट इज द मिडल पार्ट ऑफ द स्ट्रक्चर ॲज डिस्कस्ड अबोव. हा मिडल पार्ट आहे जो सुपरस्ट्रक्चर आणि सबस्ट्रक्चर किंवा सुपरस्ट्रक्चर आणि फाउंडेशनच्या मध्ये आहे. देन व्हॉट इज सुपरस्ट्रक्चर? The part of the structure constructed above the plinth level or above the ground floor level is termed as superstructure. म्हणजेच प्लिंथच्या वरच्या पार्टला सुपरस्ट्रक्चर आपण म्हणतो. मला जनरल प्रश्न आहे, व्हाय डू वी नीड बिल्डिंग्स? बिल्डिंग कशासाठी आवश्यक आहेत? वी नीड शेल्टर फ्रॉम सन, विंड, रेन अँड स्नो. वी नीड ड्राय लेवल प्लॅटफॉर्म्स फॉर आवर ॲक्टिव्हिटीज. देन वी नीड टू स्टॅक these platforms to multiply available ground space. On these platforms and within our shelter, we need air that is warmer or cooler, more or less humid than the outdoors. We need less light by day and more light by night than is offered by the natural world. We need the services that provide energy, communication, water and disposal of the waste. So we gather material and assemble them into the construction we call building to satisfy these needs. थोडक्यात काय तर बिल्डिंग म्हणजे निवारा प्रोव्हाइड करते आपल्याला. अन्न, वस्त्र, निवारा या माणसाच्या मूलभूत गरजा आहेत आणि त्यातली निवारा प्रोव्हाइड करणारी जे स्ट्रक्चर आहे निवारा प्रोव्हाइड त्याला आपण बिल्डिंग असं म्हणू. आणि अन्न आणि वस्त्रसुद्धा तयार करायला निवाराच लागतो म्हणजे बिल्डिंगच लागते, हे सुद्धा महत्त्वाचं आहे. देन कन्स्ट्रेंट्स ऑन बिल्डिंग कन्स्ट्रक्शन. बिल्डिंग कन्स्ट्रक्शन बांधताना काय प्रॉब्लेम्स आहेत, काय हार्डल्स आहेत किंवा काय कोड्स आहेत? हेल्थ कोड्स, ऑक्युपेशनल हेल्थ अँड सेफ्टी. सेफ्टी आणि हेल्थचा विचार केला पाहिजे बिल्डिंग कन्स्ट्रक्ट करताना. फायर कोड्स, इलेक्ट्रिकल कोड्स अँड बिल्डिंग कॉन्ट्रॅक्टर्स अँड लेबर युनियन रेग्युलेशन्स. ऑल these codes or constraints one must study for construction of building. Then cycle process of building construction. The main stages are, तुम्ही कुठलंही कन्स्ट्रक्शन बघितलं असेल या फिगरमध्ये बघा, ते कॉलम उभा करतायत आणि त्या वर्कर्सनी सेफ्टी हेल्मेटसुद्धा घातलेले आहेत, काही सेफ्टी जॅकेट्ससुद्धा घातलेले आहेत. तर काम करताना सेफ्टी फॉलो होणंसुद्धा महत्त्वाचं आहे. पण आपण मेन स्टेजेस ऑफ बिल्डिंग कन्स्ट्रक्शन आधी बघू. प्लॅनिंग. फर्स्ट ऑफ ऑल वी हॅव टू प्लॅन द बिल्डिंग. सेकंड वी हॅव टू डिझाईन द बिल्डिंग. थर्ड इज द टेंडरिंग प्रोसेस फॉर दॅट कन्स्ट्रक्शन ऑफ बिल्डिंग. फोर्थ इज construction process. Fifth is handover of that building or handover. And sixth is the evaluation. So these are the important stages in the construction of building: planning, designing, tendering, construction process, handover and evaluation. The elements create building loading. Various loads are taken into account while designing the foundation of the structures. Load coming on the structures are divided into two broad categories. First are the dead load and second is the live load. Every civil engineer knows these two types of load: dead load and live load. Live load is movable load, dead load is permanent load. Specific terms for dead loads and live loads: concentrated load. Concentrated load, you know that this one is the concentrated load. Second is the distributed load. Distributed load, we termed it as a uniformly distributed load, or it may be varying load like a triangular load. These are distributed loads. Then design load, we considered it for design purposes. Then undersigned load and fire load. All these types of different loads considered for dead load and live load. Wind load is also there. Then imposition of the loads. Loads must be transmitted to the structural element. The terms associated with the imposition: if the load is centrally concentrated, then it is called as the axial load. When the load is at some distance from that flange or at some distance from the column, it is called as the eccentric load. And some load is like in this way, then it creates some torsional movement. Such a load is called as a torsion load. Then structural elements. Building are an assembly of structural elements designed to transfer the load to the earth. We are discussing only the frame structure here. Can be simply defined as the beams, columns, walls and connections. These are the structural elements. The slab is also a structural element. Beams transfer loads perpendicular to its length. These are called as beams. We know that this is the simply supported beam, this is the length of beam, and this is unloaded beam. Here some load is attached to this beam, this is loaded beam. Okay. Then types of beams are simple beams or simply supported beams, continuous beams. Continuous beams means like this. This is the continuous beam. What is the cantilever beam? This type of beam is cantilever beam. One end is fixed and other is free. The lintel is also cantilever type. Then girder, joist and truss and purlins. Okay. Columns, any structural component that transmits a compressive force parallel through its center. It is axially column, generally discussed. Typically support beams and other columns. Generally vertical supports of building. Can be vertical, horizontal or a diagonal. But this member is called as a column. Then wall. These are divided into two categories. For load bearing structure, these are the load bearing walls, carries the weight of beam. Other walls, floors, roofs and other structural elements, also carries weight of wall itself. Non-load bearing walls for frame structure need only support its own weight. Example, partition wall between the two stories in a strip mall. Connections. Weak link as it relates to structural failure during fires. Often small low mass material that lacks capacity to absorb the heat. Three categories. There are connections are the pinned one, rigid one or gravity one. These are three types of connections. Okay. Then basic building components, superstructure. We already discussed. Sometimes plinth may be considered as a superstructure. Then damp-proof cores, walls and columns, floors, beams, roofs and slabs. lintels, doors and windows, chhajjas, parapet, steps and stairs, cupboard, and so many elements there are there. Electrification, plumbing, etc. We termed it as a superstructure. Then substructure means foundation. The material used for building construction, the typically used material from ancient times is a wood. It is the most common building material, relatively inexpensive, marginal resistance to the forces compared to the weight. Native wood with more mass takes longer to burn before strength is lost. Engineered wood, plywood, and some composites are also used. Plywood delaminates when exposed to the fires, and some composites fail through exposure to heat without burning. Still, this is the most fabulous material used for building construction. This is a mixture of carbon and iron, excellent tensile shear and compressive strength, popular choices for the girders, lintels, cantilever beams and columns. Loses strength as temperature increases. Then concrete. Concrete is the mixture of Portland cement, sand, gravel and water. Excellent compressive strength. All concrete contains some moisture also. Under heat, moisture expands and causes concrete to crack and spill. Concrete can stay hot long after the fire is out. Then masonry. Common terms that refer to the brick, concrete block and stone used to form the load-bearing walls. Veneer walls supports its own weight. Mortar holds units together and have little or no tensile or shear strength. Excellent fire resisting qualities for the masonry. Then cement. We know that it is the mixture of calcium silicates and aluminum silicates and aluminum ferrite. Lime, silica, alumina, these are the constituents of the cement. It gives good compressive strength, have a good setting time. It is a hydroscopic material. We use it as a binding material in concrete also. So, it is enough for this first lecture, and for more details you may please contact my administrator on his mobile phone number 87668 He is a student and you may contact him after his college hours, and email ID is given here for some your queries, and that email ID is svkulkarni72@gmail.com. It's enough in my first lecture, and you must watch my lecture till the end to get more and more idea clear about civil engineering and building construction. So thanking you. Bye bye.